Hello, welcome to this lecture on process control. This chapter is on first order systems. We have seen what is process control and we have seen about Laplace transforms. And now we have to study about the dynamics of processes. We'll be studying the dynamics of processes. Before we go to process control, before we study control of processes, it is necessary for us to know how a process behaves. What will be the dynamic nature of process? How does the process react to disturbances? What will be its dynamic nature? What will be its dynamic nature? So only when you know this, only when you know, only when you have answer to these questions, we'll be able to study the control of processes. So what helps us in knowing or studying the dynamics of processes? So what terms will help us to know about the dynamics of processes? So that is transfer function. So we discussed in the previous lecture what is transfer function. So transfer function of a process helps us to know what will be its dynamic nature, what will be its dynamic behavior, what will be its transient response to external disturbances. So here onwards, the next few lectures, we will study about processes, their transfer functions, and the dynamic response for different type of disturbances. First, we'll take up, I had also mentioned earlier, based on the transfer function, processes or systems can be categorized. So this is the first one, first order system. So what is a first order system? The first order system will have a transfer function of the form k by tau s plus 1. GFS is a symbol for transfer function. And this k by tau s plus 1 will be the transfer function of a first order system. So a function, a system or process which will have a transfer function of this form k by tau s plus 1 is known as a first order system. A process whose characteristics can be represented by a first order linear ordinary differential equation. First order differential equation. To be more specific, first order linear ordinary differential equation will have a transfer function of this form. So I repeat, a process which can be described by a first order linear differential equation, whose characteristics can be described by a first order linear ordinary differential equation, will have a transfer function of this form k by tau s plus 1, and we call this as a first is grouped as first order system. So there are two constants here, k and tau. So note that the denominator is a first degree equation in S. The denominator is a first degree equation in S. There are two constants, k and tau. Tau is known as a time constant. Tau is the time constant of the process or system. K is the steady state gain of the system, steady state gain. So simply it is called as gain of the system. So this is the first order system, transfer function of a first order system. Simple, k by tau s plus 1. There are two constants. And first degree denominator is a first degree equation in S. Well, so what are some examples of first order system? First is mercury thermometer, simple mercury thermometer filled with mercury or any other liquid, not necessarily mercury, any liquid. So thermometer is an example of a common example of a first order system. Then second one, next example, liquid level in a tank. So consider a simple tank through which liquid is flowing. So this is a simple tank through which liquid is flowing in and out. So this we'll see these characteristics can be represented by a first order differential equation, and this will have a transfer function of the form k by tau s plus 1. This is a simple liquid level in a tank. Both you can consider the liquid level H as well as the outflow. Both will have a first order transfer function with respect to the inlet variable liquid inlet. The next example is a CSTR with a first order chemical reaction. CSTR with a first order chemical reaction. CSTR or MFR, constant flow stir tank reactor or a mixed flow reactor, in which a first order chemical reaction is taking place. So that also will be a example of first order system. Suppose this CSTR, feed in, product out. This is a constant stir tank reactor. This stirrer, chemical reaction takes place inside. So this will be an example of, but the reaction should be first order chemical reaction. The reaction should be first order chemical reaction. Then that will be an example of first order system. Then fourth one is mixing tank, a simple mixing tank, where in a tank there's no, suppose you consider this, there is no reaction taking place here. Simple mixing of a process. So same as this, but without any chemical reaction. Simple mixing tank where a liquid is mixed to get uniform concentration. So that is also example of first order system. So first order systems will have a transfer function k by tau s plus 1. Tau is time constant, k is steady state gain, and these are the examples of first order system. The first order system is also known as first order transfer function. System with first order transfer function is also known as first order lag, lag, first order lag. So in the next lecture, we'll take up these examples and we'll show how, for example, how thermometer gets a transfer function of this form, k by tau s plus 1. We'll derive this transfer function, tau s plus 1. Similarly for other systems. And we'll see how this first order system responds to different types of inputs, different types of forcing function inputs. So stay tuned for these lectures to be notified of these lectures, of these videos, which will be published soon. Please subscribe to this channel and also please share it to your friends. See you in the next lectures.